Hey, Carl.
Hey, Mark Antoine.
How are you?
Good, thanks. I was curious. So, what's the Rama situation? Did you look more into it and any
I did
progress?
look. I did look at some depth, not as much depth as I would have, but I mean, I got it started, and I'm. I, no, I both basically read the basic docs
Mhm.
and started a few basic. I'm annoyed that it's not open source, but I kind of understand. It's a bigger project than I expected.
Mhm.
Very, very ambitious and smart, and oh God, there's so much right in there. There's a lot that I'm doing differently, but I'm like, should I try to build on Rama because there's so much that they've done right. On
Yeah.
the other hand, I realized, and here I don't know how to. Okay, let me get deep into that quickly. Um, their projections are really, they call them indexes, and I see why. They're not. There's no processing on the projection side, right? Besides ETL. So it's a materialized standing query, which is absolutely fine and appropriate, or rather a materialized query result that is maintained. I think it's a very good thing to do, and they managed to make it hugely scalable, which kudos. I was trying to do projections as how much of the classic transformation of events into entities can we push to the database layer, because it's really repetitive. Like there's a lot of complex operations that belong in other layers, and so you'll put a query on the event, somebody will pick it up, do the calculation, and put the result on the event stream, right?
Mhm.
And that's totally valid, but a lot of event sourcing, projection, transformation doesn't belong in that complex calculation cycle. It belongs in the, oh, let's just compute a small uh, aggregate of the events that mean there, and let's calculate that and put that in the state. There's a nuance in that. I'm having a bit of. I realize I kind of painted myself in the corner by the strong event um, projection distinction, because sometimes I'd like to know the past projection state without recalculating it, because it's become an artifact in the next calculation. If you
Mhm.
have a more layer, more than one pipeline, it becomes a bit complicated my way, and it also becomes difficult the Rana way, because their indexes are not projections. They're
Mhm.
okay with it because, oh, it's just going to be computed by another projection, by another stream, and that's fine. It's but that means there's none of that automation thing I was doing. So I'm still weighing the pros and cons of the different designs. That's fine. There's a lot of things right in their design, no question. It does not. I'm not sure I could. One thing I liked about my design is I could do some of it optimistically in the client. Cannot do that with Rama as such, but it may be possible to do for a subset, but carving the subset is not a Rama concern.
Mhm.
What I'm really banging my head against, or should I stop there, or do you have comments to what I said so far?
I don't have any comments. It's kind of abstract to me, so I think I'm only like 50% following. It's kind of a feeling more than a direct following.
Fair.
I mean, I think what I understood you to be saying is that I think it builds off of our conversation last time, like a couple weeks ago, where you sometimes need to know previous states to calculate the next state.
Yeah.
And I mean, I guess if I understand correctly, the problem in your situation and also in Rama's situation is that they only have this single. single layer of these pre-calculated states. And it's been now a month probably since I looked at Rama, so I forget the terminology, but I think you said they're calling that indexes. And so if you have basically an index that conceptually kind of builds off of another index, you just have to create that as a separate index. You can't have indexes feed into others. And there's no concept of like the history of the state if you want to try and like reduce or whatever you want to use the word of, relook at the history to come up with a new derived state. Is that an accurate sort of?
Yeah, up to the last sentence, it's absolutely true. The index doesn't look at the other indices. It can look at more than one history stream, but it doesn't look at the indices. The history streams are very much segregated by commands in Rama, not by. It's not a federated architecture that way, but that's okay. But when you said after that, you said something else about after that I felt, that might not be accurate, and I lost it. Does it have access to past history? No, it is a full event streaming platform. In theory, it has access to past history, but I'm not sure. Maybe not. Maybe it's just the running aggregate time window, which is what I was trying to do as well. So how much can they exploit the past aggregate? I don't know. I have to dig deeper into that, but I think not. So the conceptual aspect is very similar. There's no good way in either hyperknowledge as it exists or Rama to build from the previous layer of computation. There's the layer of events, there's a layer of projection or indices respectively. This builds on the layer of events, and that's it. And sometimes it's not enough. There's no what I'm thinking about doing is maybe reify the calculated states into events, but that's costly, right? It's about materializing each intermediate state of calculation. Mm-hmm. That's definitely something I would like to not do always, not have to do. But there's a lot of stuff that is, how else do I do it? So yeah, struggling with that part. The part I'm confident about, still confident about the basic event streaming stuff. Still thinking, okay, the real problem I have in terms of going beyond the basic event streaming to what is it we're trying to build for CDL. It's when an event contains a statement, right? The statement is a phrase. It contributes to an understanding of an entity, right? So there's the entity, which is everything we believe about that entity. And that's a projection. Or maybe it's a subset, it's a point of view on an entity, fine. Or maybe it's a sub-aspect, but it doesn't matter. Statements are usually, in a way, the belief unit of what the statement talks about is much smaller than that. It's, I believe this about this entity, or this state of affairs, or whatever. Mm-hmm. So what is the proper belief unit? And that's a CDL concern. Is it the statement itself? Well, I think that often you have the statement, some people will believe a statement, some people will believe the negation, some people will believe a superset, a subset, something with intersection, something mutually exclusive. So there's this whole cloud of beliefs that are clearly related to the core statement, assuming they're unambiguous here, which is another story. Mm-hmm. But so it's kind of in the belief neighborhood of that statement. And if you're talking about social knowledge, you kind of want to know how many people believe this thing, which is mutually exclusive, such as a negation, but not only, because not all questions are yes/no questions, right? To come back to the classic Tim's classic example about pandemic versus lockdown economic cost. Like I could have a belief that I believe the economic cost will be between this much and that much, and I believe it will be between this much and that much. There can be overlap. There can be overlap. There can be mutual exclusion. Are our beliefs compatible? How much? Is it, if it's a normal distribution, we can calculate kind of the common integral and say this is how much overlap there is between our beliefs and how likely we are to both be right. But what I'm saying is, socially, if I asked, do you believe economic cost will be this much? We should get a kind of distribution of so many people believe it's this likely to fall in that bracket, and so many people think it'll be more, so many people think it'll be less, and a kind of population distribution. That's ultimately would be the goal. Maybe it's very idealistic to think in those terms, but certainly without going into having all the probability distribution and doing the Bayesian work, knowing what are the statements that are related to this one, because there is a correlation between belief in this statement and this other statement, basically, either because it's compatible and compatible, but they're not orthogonal. What are the non-orthogonal statements? And that's the kind of belief. And of course, predecessor consequence is another axis, right? Alternatives is an axis, but predecessor consequent are another axis. So what is the statement? How do I define the statement neighborhood? And when, to come back to event sourcing, when I'm dealing with projections, I'd like to know, okay, there's this projection, it's in this state, we believe this. Maybe it's one person's belief, or it's a social truth composite. But what are the events that led to this state?
Right.
And if there's an update, that means one of those events might have become obsoleted by the update, and hence it's not part of the provenance of this state anymore. But sometimes it is, because you've done a kind of running sum of all the kind of integral of everything that led to that belief. So can I distinguish that? Not yet. But I'd like to be able, like the goal, the real goal is to be able to say, oh, if I update this, I need to update that. Right? So knowing what has contributed to this belief is important, so that I know I can understand the update cascade.
Why don't you just, I mean, this is going to sound naive, but why don't you just store that either as like some sort of structured thing in the database, like a JSON column, or some, relation, like, hey, for this thing that, is fully computed here, is fully projected here, here's its projection ID. Sorry, I'm just making up words here. Here's its identifier. And then here's the rows, that currently all contributed to it. This one is from this type of thing that contributed. This is the identifier, and this is the type, and this is the other thing contributed. I say that, and I know that there's a lot of work involved in actually creating that, but that's what you need, right? You just need something that stores that past, and you need a plan for how to update it when things change, right?
What I'm saying is, on the one hand, in the case of, okay, is the whole state of the projection, or is it each column of the projection? I don't know yet. I'm not sure. These are the details I'm trying to determine. Am I interested in the updates, in the events that make up the current state of the projection? And then what happens when an event gets obsoleted? How do I know that it's obsoleted? I have to know up to a point. What I'd have to do if I had infinite computational resources, I'd have to rerun the event stream without that event. Oh, no difference. So that means that event is not contributing to the state anymore. But
okay, I think I see. There's sort of proving the negative. That's the wrong phrasing, but there's kind of a thing where there's so much to keep track of, it may not be possible to have a summary.
Exactly. I'm not sure I'm trying to reduce it to something tractable, or at least the point is, I'm okay if I have a system where any such request gives you a cursor, as long as the cursor is roughly ordered, a bit like a tree. Give me the 10 most recent things and 10 most recent thing. And as you go down the tree, you get things that have contributed less and less. If there were a way to maintain that order, I'd be perfectly happy if the resulting set is infinite. But right now, the set seems untractable. That means that when I do a request, I'll get the whole world, which is unacceptable. Or I have to find a way to say, well, this is not part of the story anymore. Or I think what will happen is I may have to say, here's the state. Here's the event that got me to that state from that previous state. And if you're really curious about how, and then you can go back, like you can unwind the history, which is fine. But what really something should be able to ask is, hey, it used to be this state, it got to that state. What changed that column? What made that column flip? At what event did that happen? And again, if I could answer that precisely enough, might be good enough. And that's not terribly hard. Maybe that's how I should see it. When did that column acquire that value? And go back in history until you see the flip. And then the event is responsible for that. What I could do is have, and I've thought about that option, have one event per column, like the latest event that flipped that column.
Mm-hmm. What are the columns?
The attributes of the projection, like the projection is a frame, right? So each key of the frame, each slot of the frame, or each column in the database as such, because I'm representing in the database.
Mm-hmm.
I could say, well, this is the last event that flipped that one.
When you say frame, are you referring to
Minsky? Yeah, Minsky, or classic AI frames.
I don't know that reference. What's a classic AI frame or a Minsky frame?
It's basically, in a way, it's this thing that gave us OO before OO existed, but it's a schema, and the idea is that each property it's a schema with rich properties. Each property can have a default value. It can have an acceptable range. It can have, like, there's a lot of intelligence about each value in the frame, but it's basically think of it as a named dictionary with metadata.
Well, so the thing that it triggered for me, tell me if this is related or not. What was that? Oh gosh, there's like that encyclopedia of, and I'm forgetting the terminology of, like, not frames, but concepts. Was it from Stanford or something? It's like, here's all of the things that exists on, or hits, all these different.
Yeah. I gave that example often. Those are frames, absolutely.
Okay. All right. Yeah, makes sense. All right. So what you're doing is you're sort of, those are the frames you're trying to fit things into, and your projection has a current, sort of value for each I guess slot in the frame.
The Stanford frames are linguistic frames, and I think that's extremely important. I want to handle them. Now, the event frames may not be those frames. Like, they may be, somebody asserts that does it fit in the Stanford thing? I don't know. It's a frame. It's still a frame. Now, what is being asserted will probably take the form of a Stanford frame, right? But somebody asserts that blah, that's a kind of maybe it's in the Stanford frames or not, I'm not sure.
Well, what are the frames? Like person, like actor,
And
asserts,
then
assertion is the frame.
And then there's the projection frames, and those would be pretty much like database tables or OO classes, right? It's schemas of this is how I view this entity. This is the data that I want to have about this entity. This is the mutable state of that thing.
Yeah, but what are those for you? Was it topics or themes, or what do you call them?
For me, all of this is topics. A topic is anything you can talk about, so it includes all of the above.
Okay.
Okay, it's the ground of the ontology. There's no superclass to topic. It's like object in OO. It's the root, or type. It's the root of the hierarchy.
Well, how do topics relate to your database tables, though?
Well, each topic needs an identifier.
Okay.
And that means the events have to have identifiers. The anything you talk about, and here's a problem. We usually use names to designate topics, and that's well and good, but the reality is there's a many-to-many relationship between names and concepts. And since you can talk about concepts, they're topics, so that means they need an identifier, which is not exactly a name. Now, an identifier is a name by another name, so to speak, but it's opaque. It doesn't have, and my innovation is making sure that they can change, because concepts are fluid, they can be forked, anything can happen to the identifier. So the identifier is, you cannot, it may get altered. So, and then you need to have history. That identifier became those identifiers because we introduced this distinction.
Okay.
But that doesn't matter. When you have a name, you have a default, oh, I'm interpreting it as this concept. You give that an identifier, okay. And then you realize, oh, actually, there's this nuance, this nuance, this nuance. I meant this one.
Mm-hmm.
And that means a retrospective reinterpretation of the statement, which, let's not go there yet. Let's just assume that the schemas are immutables. They're data structures as such, are immutables, they're value objects. Those are not, there's no evolution there. There may be an evolution of how we interpret the schema or what the schema is supposed to represent, and that's a concept, and that's mutable. But the schema itself is a data object, it's immutable. So I can use immutable identifiers there, like probably an IPLD hash or something like that. But so on the one hand, we have the frame such as, hey, I calculated, this is what I believe about entity X. Entity X will have a name, maybe a UUID, whatever, it doesn't matter, because that shouldn't change that much. There's the problem of federation that maybe we didn't use the same identifier, but that's different. There's no reason for me to change my identifier unless I want to align with someone else. But that's better done with the translation table. There's the state of what I currently believe about this entity. That's a frame. It's a data object, but it will change all the time. I can snapshot it, and that becomes immutable. But the state of my belief about entity X, that's mutable all the time, as opposed to the entity identifier, as opposed to events which declare new beliefs about the entity, which are immutables. Events are immutables.
Well, I'm still having this is, I mean, I don't know how important this is to solve right now, because you're kind of, I think, still figuring things out, and I don't know how much helpful I have to offer, but what I do have trouble grasping, and maybe it's because I've forgotten since our last conversation, or maybe I never fully had, is I don't know what's static about your design and what's mutable. Because I remember you were making these tables on the fly, and I can't remember like what's static about their schema.
The schema is an immutable.
And by schema, I mean the database schema.
Yeah. The schema is an immutable. Well, okay.
You
The
create
table.
tables, so in my mind, that would be an immutable. That would be a mutable schema if you're creating new
Okay.
tables.
That way, the schema as a whole, yes. The schema for each table, each
Okay.
table's schema is an immutable. Now it's
And what does it
possible.
have?
What?
What does it have? What are its columns?
Whatever you want. But the problem, the thing is, you declare at some point, oh, I want to make a project. I want to create a projection with that schema, and that declaration, you're saying, I want a projection with that schema. That's an immutable. Now it's possible you'll stop caring about it, and I'll kill the table at some point because,
Right.
or archive it or whatever. But the schema itself is immutable. That is, if you want to add a column, in a way you're declaring a new projection, and that means I'll have you create another immutable schema and say, oh, I don't care about this schema anymore. I now care about this new schema.
But what are the choices for the columns of a new table?
Again, pretty much whatever you want. What's
Well, I mean, in your system, I mean, there has to be some rules to it, right? Like, okay, you can have a relation and it refers to another table, like, oh, this one is a table name, so it tells you this other table that it's referencing, and this one here is the primary key of that table, or this one is strictly data, where it's like a string and it's it's known to be the aggregate of like I don't know what well, let's just call it int. It's a sum over some other table, all of the things in there, and that just
right. It's much
like,
more it's much more limited than that now. When I said whatever you want, I meant base. Right now it's basic scalars or reference, and the reference are not even foreign keys, though I'm working on that. That's intended. The important thing is that you can declare this projection is computed from those events, and here's the function that updates the projection when this event happens.
Okay, so that's the sort of the basics, that there's a stream of events, there's a projection function, and then there's the resulting projection table.
Yeah.
Okay. And the projection functions, those are like statically defined in the code, or how those are configurable? Like the code is designed to allow dynamic projection.
It's a little JavaScript snippet, and you can execute it on
Oh,
the
that's
fly.
right. Yeah, I remember those now. Okay.
And eventually I'll move to WASM or something or I'll allow WASM as an option for more efficiency. But the whole point is to make it really easy to maybe eventually move that queue to the database or distribute it or whatever. It shouldn't matter where it's executed. Yeah, there's a lot that's floating, but basically, yeah, how much do I want to refine my projections, snapshots? How much do I want to allow, like right now, the projection reducer function only looks at the current state of all the projections involved in the event. Like the event can speak about many entities. So all of those, I take their projections and give that to the projection function. So it's allowed that, and the event itself, of course. Is that enough? And in particular, when it's looking at an event that happened in another dependent stream, does it have access to the projections of that stream?
I mean, where my brain's going with this, and it's tentative, because again, I feel like I only like half fully understand your system, but you have to, if you want to be able to sort of quote unquote like undo projections or like recalculate efficiently without having to just rerun the entire, I guess,
Event stream.
Yeah, event stream, you're probably going to have to limit what those projections can do, because if the projection is a lossy projection in the sense that it sort of computes some endpoint but loses track of how it did it, there's not going to be a way backwards. You have to rerun it. I think.
Yeah, which is okay.
Okay.
The whole point of event sourcing is you don't care about the computation, you can rerun it.
Okay.
Rerunning should be cheap-ish. What you do if you want to control that cost is you take snapshots. So you only rerun from the snapshot.
Yeah.
Okay, and
so
that's
some way of identifying that, like, past here, nothing has changed, so just reuse the snapshot from there.
Yeah.
Yeah, that seems like a good idea.
But yes, rerunning is about, like, computation is not that expensive, and the idea is, yeah, go ahead, recompute.
Mm-hmm. All right.
For what it's worth, it's a way of doing things.
Mm-hmm.
What Rama does is the projections are data structures as opposed to database objects. And that means they live in a memory, they're fast. There's, of course, a size limit, but I'm sure like 99.9, like what Rama does is, because all the construction of the indices is done by Rama functions, they can decide on sharding and distribution and this and that, because the logic of the indices is Rama logic. And that is awesome. That is really awesome. But the cost of that is there's this big dichotomy between the events, the indices, and the reality is there's not, how should I put it? In their world, the projections are pretty simple. In the sense, it's simple aggregates of everything that happened. You know, like the event, the social, your event stream of how many likes, stuff like that, right? There's no, oh, I'm doing this big computation and storing the results and altering altering what I believe about this. There's only updates. How should I put it? All of the updates are aggregations. There's no altering update. There's no update that says, oh, what's gone before has not been true. You may, remove your like, but so you change the counters of how many likes were canceled or whatever, right? But it's not the same as saying, I don't know if you can edit a past post in their tweet stream. I'm not sure that's a use case. Whereas saying, oh, I believe this and now I believe that, of course, it's an override. You're not deleting the past one. You're just invalidating it. But it does become not part of the picture anymore. And there has to be a way to express that, is what I'm trying to do. Which I'm
And what about doing it that way, where you move forward? If you treat all the events as immutable and can always compute on top of it, is that not an option for you?
That is an option, but I mean, the question is, which of the past events are relevant to the current state? If you ask me, how did you get there? I'd like to be able to say, here are the statements that led to that state of belief. Now, is it all the statements? Maybe it is, but it's a bit much. I'd like to be able to say, no, these are these were the flippers. These were the most relevant, or this is what really contributed. This is where I'm still struggling. And for that, this notion of unit of belief, what's the neighborhood of a statement? Because the projection is not one statement, it's composed of many statements. Now, what is the statement unit? Is it the individual statement or is it statement neighborhood? Still struggling with that one. Again, in the view of providing social truth as opposed to single belief. I want to say, well, and again, it's not important to say, here is the status of the column. It's more about saying, what is the demographics of belief about this? And what are the units of the demographic of belief? It's what is being, not in terms of the demographics, but a unit of what is believed.
Mm-hmm.
That is what I'm still trying to identify. Especially in trying to get, like, I don't, understanding the dependencies and changes, and I don't know if we can ask people, but I suspect very rarely.
Ask them what?
Why did you change your mind about this? Or what led you to that belief? Will they know? Will they have a good answer? I think we will do it. It's worth asking.
That's logic. I mean, they may not be good at it, and they may be wrong, even if they say it's what it is. But I mean, you can ask them, like, what's your argument, or what argument convinced you?
Yeah.
What's your next milestone you're aiming for? Like, what are you trying to? What will be the next thing you say? Oh, this stake in the ground.
I keep talking about social truth. I need to nail that data model. That's important.
What does it mean for social truth?
Like when I say demographics of a belief, what does the demographic look like?
Okay, it's like group definitions or clustering or whatever.
Yeah, well, again, basically, it's about saying, here are all the different beliefs, and here's how many people are behind each of these. That's the endpoint, but what's the data structure that leads to that? I probably want to keep track of who is behind each belief on the one hand, because if somebody changes their mind, I need to not only add them to the new one, but remove them from the old one. So I need to keep track.
Definitely.
On the other hand, I don't want to carry all of that every time I give you a social belief. I want to just give you, here's the demographics, here's the statistics, right? So what's the right data structure so that I can both keep an updated count, and I mean, it's not, some of it is easy, right? I can just have tables and keep a running number, and it should be enough. But
well, are you familiar with hyperlog? As
not sure.
7 years ago, when we were looking into this, it's a probabilistic data structure for cardinality of a set.
And so yes, I know about that.
Way to keep track of something. I mean, you'd have to figure out when you needed to actually recalculate, but for a time being, you could potentially use it. You know,
I've been thinking a lot about using kind of Bloom filter-ish structures, and because you can do cardinality approximation using a Bloom filter. And that remains a possibility. Yeah, because I'd be happy with the approximate demographics given the constraints of the system. But the Bloom filters are terrible at removal.
Yeah.
I don't know about hyperlog. Does it handle?
I don't think so.
The statistical structures are terrible at removal, basically. They're often monotonic.
Yeah, I think it would be like a performance improvement.
One thing that can be done, of course, from the classic, what is it called? You basically count the additions and the removals separately, and you subtract.
Yeah.
So the additions and removals both grow monotonically.
Mhm.
That works. It's
Good idea.
classic and efficient. That's what
Mhm.
CRDTs do when CRDT counters do that.
Mhm. Mhm.
And it's perfectly appropriate to these demographic structures. So I might do that. That's something I've thought about. But yeah, tempting. But again, think of, and this is really speculative. If you have a bunch of possibilities, some of which overlap, how do you represent that to give the demographics of who believes what? There, this is a UX problem, not the data structure problem.
Well, hmm. It depends on what overlap means. If it's literally like you have some sort of mathematical quantification of the range or the belief, then you can actually quantify overlap. But if it's like, because when I'm working on these things, it's all strings, it's all um,
Yep.
standalone claims. And so, you either ask everyone, to review both of them, and then you get, exact overlap. And that, I kind of mean that as a joke, because obviously you can't expect users of a system to all, respond to a request, and you're gonna have, thousands or more of these types of requests. You can try and automate it by, using, let's see, some sort of similarity vector, or some sort of, some similarity metric, but I don't even know what that would look like, doing that actually in practice. And it would be probably fraught with, problems and inaccuracies. You could try and extrapolate from a small sample, like for a few people, who have evaluated both. Like if 100% of the people who've evaluated both, are in agreement, then you say, okay, we think then most of the other people who were in agreement were like that, or try and calculate a similarity between the people who had done the, you know, evaluation of both. It's the similarity between them and other users across other statements they've evaluated together. I don't know what else there is besides that.
The
Some combination.
I think the sometimes you have a bunch of ideas, you don't know the relationships yet. What you'll ask someone is, okay, let's start with what you propose or what you believe is, which is the closest to what you believe, and which of the other ones are really incompatible, and which ones could be also be true at the same time.
Mhm.
Um, which you may or may not believe, but which one could be true at the same time? It's a different question, right? Which ones cannot be true at the same time, and the partitioning. And then it's really interesting to see, of those that could be true at the same time, which ones could you believe, and of the other ones too. Now the problem is, again, at some point there's too many options,
Mhm.
especially if you allow abstractions and stuff like that. And I think it's really good to get people to start with precise belief, say, oh, is there a kind of larger category it falls into? And then we can do the disjoint versus overlap in
Mhm.
the more abstract categories, which should be fewer, instead of asking them about all the individual possibilities. And sometimes that means what is the distinguishing factor? Again, it's very much the animals game, right? Well,
Animals game, what's that?
oh, that's a classic. Uh, when you learn when we learned computing in basic ages ago, one of the first examples we were given is the animals game. Think of an animal. Oh, I think you thought of a horse. You didn't. So what's different between the horse and the animal you thought of? Okay, it has fins. Okay, and what animal did you think of? Oh, it was a fish. Okay, so guess again. And I think it was a fish. Oh, what's the difference between? And then you basically at each point you ask, what did you think of? What's the difference between that one and that one? And you create a decision tree
Okay.
from the user's answers, and that
Is
means
this something people actually implemented? Like something that
yeah.
would question them?
Yeah. It was a silly game. It was not that fun, but it was an example of,
But does it
well,
need like a knowledge database? Like how does the program know that based upon fins that fish are a good answer?
no, it doesn't. It asks the person, what did you think of? Oh, it's not a horse. Okay, what did you think about? Oh, a fish. What's the distinguishing characteristic? Fins. Okay, cool. Then next time, okay, let me try
Oh, it
again.
learns it.
And it learns it.
Oh,
It
that's
does.
funny.
It's very simple. And it creates a
Yeah.
decision tree. And then next time it guess, oh, let me try to guess your animal. Does it have fins? No, it's a horse. Oh, okay, no. Okay, so what else could it be? And was a distinguishing characteristic? And that becomes a binary tree.
Yeah, that's cool.
It's a stupid game. Now, of course, making it a binary tree, it's not balanced, it's not optimal. And you need to find what are the key questions. But I'm saying it can be rebalancing can be made part of the system,
Mhm.
and making it optimal and useful can be made part of the system from statistics. Like, what are the characteristics that help you really distinguish, partition the set, and identify outliers and blah blah blah, and then you you can situate people with very few questions. Someone I knew actually did a statistical tool. It was for making shorter exams. It was about assessing the knowledge of someone in as few questions as possible. So it looked at all people answering these long questionnaires. It looked at correlations and dependencies between right and wrong answers.
Mhm.
And it created a kind of optimal path. Let me ask this question that will, partition the probability space into, and here's the next question that will partition into, and so on. So after 5 questions, I kind of know where you are, where you stand in the knowledge.
That's cool.
I don't know if that research still exists, but
Hey, do you mind if I change directions real quick?
yep.
You shared this paper, Opportunities and Risks of LLMs for Scalable Deliberation with Paulus.
Yeah.
Did you read it? Did you have any thoughts and reactions to it? I haven't read it.
To be absolutely honest, I haven't. I skimmed it. I read the abstract and I skimmed it, but I didn't read it in depth. So I don't think I want to pretend that I have a very informed opinion on it yet. I knew it was of interest to the group, which is why I sent it. But a lot of people are looking at Paulus. Where's Graphologue? Ooh, nice. I just saw Graphologue in general. Missed that. Okay. Where did I even put that thing? I put it in the docs, I guess. Scholar, oh yeah, related projects, probably. No, related academic work. God, it's been a while. No, yeah, it's just on my list. Sorry.
Oh, it's no problem. Just wanted to check. I jumped down to the augmenting, not replacing human intelligence.
The problem is, it's not that whether AI can replace humans or not. The question is whether it will, because a lot of people with money are eager to replace humans with AI, whether it's ready or not.
A lot of people what?
A lot of people are eager to replace humans with AI, whether it's ready or not.
Yeah.
But that's a political issue more than the scholarly issue. But yeah, I care about that one too.
Yeah. It
I mean,
seems
that's
like
what
that,
that's what Timnit Gebru is saying all the time, right?
What is she saying?
That the real problem with AI is not whether it will take over humanity, it's whether it's actually used as a way to enclose and capitalize knowledge.
I haven't seen what she's said recently.
She's
Maybe
been
I
saying
should think
that
forever.
for, yeah, that's her main thing that she keeps repeating.
Okay.
It's about power.
That I would
It's
agree
not.
with. Power. Yeah. I mean, there's a lot of people who will not be working in the same way they did.
Yeah.
It's
No, but
knowledge
there's a
work.
lot of people who are appropriating knowledge by making sure that knowledge goes through a certain process.
Mhm.
So they're kind of creating a new choke point in Dr. Ross terms for knowledge work.
Making a what?
They're creating a new choke point. Like knowledge work will go through this thing that we control and that people have to pay us for.
Mhm.
So they're creating a new gatekeeper, a new choke point. Like things have to
The
go through
gatekeeper
that
work,
funnel.
like if your knowledge doesn't get into our training set, it won't become part of the LLMs and so basically not be considered, or what is the
That's
how does
one thing. No, it's more everybody's going to use LLMs, so that means you have to pay us for any work you do. And everybody's knowledge is in our LLM. So the fastest way to access anybody's knowledge is not through them, is through our LLM. And again, please pay us to access it.
yeah, so like I don't know what the right word is, type of mining or rent seeking, of knowledge that you should be out there. It came from this person.
Yeah, enclosure.
Enclosure. Okay. I'm reminded of Jaron Lanier's book. What was it
Yep.
called? Who is the internet, or what was that one?
The book to read right now is the both of Dr. Rowe's latest essays. There's the last one is the Internet Con, and that's about more interrupt. But the previous one is called Choke Point Capitalism, about the way that companies put themselves as necessary intermediates in any transaction.
Okay. I haven't heard of either of those. Thank you.
Pleasure. Hour's over. I have tons of work to do.
Yes, of course. Yeah. Thanks, Mark Antoine. It's fun chatting.
Yeah, and thanks, Carl. It's been very useful, and
I hope so. Sometimes I worry that I'm playing the, sort of dunce to your work, but I feel like I don't know, sometimes that helps clear up confusion.
it does. It does. And no, and the reference last time was really useful. I'm still
Yeah. Well, I have to admit, I think I got that through Nick. I haven't been watching them as closely anymore because I've been too busy, but that they're, Nick, whatever his last name is, the guys with the debate chat or the debate bots or whatever.
Okay. Oh
They're
yeah,
super
yeah.
knowledgeable. I mean, they're just
Oh
super
God, yes.
all over the place with, paying attention to things and new ideas. They've been doing some really cool stuff on vector databases.
I'm aware.
Interests you, but I could find, or if you're in that chat, you can find, but they've been posting some blog posts. So I guess it should just be on blog.argueflow. Argueflow, that's what I'm doing.
I've been following the Argueflow work. It is fascinating.
Yeah. They've got a new blog post out from yesterday comparing, looks like PG Vector and Lantern DB, which I don't even know what Lantern DB is.
No, I didn't either. They're not keen on PG Vector, but I should look their latest.
Yeah. Cool. Well, I'll let you go.
Okay, ciao, ciao.
Take care.
Thanks.